Okay, final review over radicals and rational exponents. So we have to simplify first. The fourth root of 64 times x to the third times y to the sixth. So it's a multiplication problem. So I lay this out. Do I have a radical? Yes, I do. So I'm going to write it in a quantity to the power of 1/4. Now, inside the quantity, you got 64 times x to the third times y to the sixth. So my factors are 64, x, and y. Now, what happens to the exponents? Well, we distribute 1 to 1/4, that's 1/4. 3 to 1/4, that is 3/4. And then 6 times 1/4 is 1 1/2. Okay? Got that? All right, now, hold on a second, make sure I got something right here. Yeah, okay. So none of those are negatives. We don't need to mess around there. That line's only to make negative exponents into positives. I don't have any negative exponents. Now the third line is to separate, it's for two different purposes. Okay, first is to separate your whole exponents from your fractions. So I have a 1 with a base of y. It's y to the power of 1 times. Then I put all my fractions, okay? 64 to the 1/4 power, x to the 3/4 power, and y to the 1/2 power. Okay, now look at these fractions, see if you can get rid of them. You have to do that here. So can you get rid of the 64 to the, can you rewrite the 64 to the 1/4? Well, no, I can't, because 64 is not a perfect fourth root, and x and y definitely aren't. Okay, so, or at least those fractions aren't on the bottom though, so we don't have to mess around there. All right, so now I still have fractions on the top, so y to the first, okay, that doesn't need a radical, that's a full exponent. Now when I get to these fractions, I make radicals. Since I have 4s and 2s, I'm going to make a radical of a fourth root and a radical of a square root, a second root. And we get rid of these, so we're going to have 64 to the first, which is 64 times x to the third. Now in the square root, you're going to have y to the first, and you can just put y. Now your radicals, y to the first is just y. Now in the radical, you got the fourth root, and you got to put the x to the third, and you also have the square root, and you want to put your variable y. Now I need to see if I can simplify the fourth root of 64. Okay, we know it's not a perfect fourth root, so we try to divide into it. And then on my fourth roots, okay, I get pretty much 16 or nothing, okay. 16 works, so I put 16 and 4. So the fourth root of 16 is equal to 2 whole. So I place a 2 out here and a 4 in there. Okay, that's it. You also could write that as that 1/2 is 2/4, and then you can just make a fourth root with y to the second, so it's all in the same, but that's up to you. Okay. Next one, number 2, the fifth root of 32 times x to the 6th times y to the 7th. So again, nothing but multiplication going on here. So I write my quantity to the power of 1/5, and you have 32 times x to the 6th times y to the 7th. So my factors are 32 times x times y. 1 times 1/5 is 1/5. 6 times 1/5 is 1 1/5. 7 times 1/5 is 1 2/5. Okay? None of them are negatives. So my full exponents, we have a 1 and a 1. So x to the 1 times y to the 1. Then I cross those out, and now I write all my fractions. 1/5 with a base of 32. 1/5 with a base of x. And 2/5 with a base of y. Okay, now, you have to do this right here, what I'm doing right now. So the fifth root of 32. Well, I flip over, and 32 is a perfect fifth root, it equals 2. So this is now 2 to the power of 1. Okay, that 1 is still there, it's just brought to the 2 as a power. Now these are variables. So we have these fractions still, but are they on bottom? No. Okay. They're on top, so I got x to the first, which you can just write as x. Y to the first, you could just write as y. 2 to the first would just be 2. And then with these fractions, you cross out the fifths and make a fifth root out of that. So it's x to the first times y to the second. Now, normally that can be your answer, but you know, we got a 2 outside, an x, a y, and then my fifth root just has nothing but variables, so it'd be x times y to the second. Okay, number 3. These are both square roots, okay? So it's all multiplication, okay? So another one. Now with multiplication, if the roots are the same, okay, and you got 2 roots, but you're multiplying 2 of the same root, it's going to be just one quantity to the 1/2 power. And then I take 8 times 4, 40, which is 320. On y, it's going to be y to the 7th. So you have 320 times y. 1 times 1/2 is 1/2. 7 times 1/2 is 3 1/2. None of them are negative. Okay, so I have a 3 as my full exponent. I write that first. Then my fractions are half and half. The first half is on the base of 320, and the other 1/2 is still on the base y. Okay, perfect square. 320 is not a perfect square. Okay, I know it doesn't go that way, but it's not. Okay. All right, none of those, the fractions at least are not on the bottom, okay? They're just on the top, so we have y to the 3rd. Then when I come to my rational exponents, I make a radical with a 2, okay? Inside I put 320 to the first, which is 320. And then y to the first, which would just be y. So you got y to the 3rd times the square root. You put the y in there. Now you got to see how much of that 320 you can get out. So dividing 2. So 320, I go up the list. Eventually you will find that it's divisible by 64. 64 and 5. So the square root of 64 is 8. So times 8, and then just put the 5 in the radical. Okay. Number 4 is kind of a cheap problem. I probably wouldn't put one like this on the test, but you got multiplication, but it's 2 different radicals, a 7th root, a 3rd root. So I put 1/7 here, 1/3 here. Okay. So 7, 7. Okay, so what I do with the 7 is I add the powers, okay? You're going to have 1/7 plus 1/3, okay? (10 over 21), okay? Okay, no negatives. Well, you got the fraction exponent. I don't even have a 21st root, okay? So it's not on top. So now you make a 21st root. And inside you have 7 to the power of 10. But right here, if I go 7 to the 10th power, I get that answer right there. Just put it. I know this is a crappy problem for me to do. 4, 7. And that's going to be our final answer. I can't really try to divide because I don't have a 21st root to look at. Okay, number 5, okay. Division's like multiplication, okay. You can't make one single parentheses, it's got to be 2. So it's a 1/2 and a 1/4. And inside you're going to put y to the 3rd and y to the 3rd, okay? So y over y, and then 3 times 1/2 is 1 1/2. 3 times 1/4 is 3/4. You take the smaller one from the bottom and minus 3/4. So I take 1 1/2 minus 3/4. Okay, I got 3/4. Okay, it is not negative. Really, it ends up in a simple problem at that point. You're not going to find the 4th root of y. It's not on the bottom. So I make a radical of a 4 and put y to the 3rd inside. So the 4th root of y to the 3rd. Okay, number 6. That is a multiplication problem. Okay. but you don't have these radicals, these roots, so you don't have to rewrite it. You just start rolling 32 to the negative 4/5 power. Well, now that you have a negative power, you're actually going to use the second line to reciprocate it to the bottom, and then 4/5 becomes positive. Now, in a problem like this is why, okay, 4/5. You've got to check 32, the fifth root of 32. See, the fifth root of 32 is 2. So now this becomes, the 32 and the 5 go away, and we have 2 to the power of 4, okay? That 4 doesn't go away, it's just 2 to the power of 4. Now, I don't have any fractions, period. I mean, no fraction exponents on bottom, none on the top. So 1, 2 to the 4th is 16, 1/16. Okay, number 7, y to the half power times y to the third. It's times, and I do not have them. It's not in a radical formation, so I don't make that parentheses. I just start rolling. I got y, there's another y, so we add the exponents. 1/2 plus 3/10. It's 5/10 plus 3/10. It's going to be 4/5, but I'll show you. Okay. It's not negative. The only one you got is the fraction. You're not going to find the fifth root of y. It's not on the bottom. Now I make the radical 5, and then y to the power of 4. Now I can't simplify y to the power of 4 at all. Okay, number 8. Another multiplication problem. 8 times x to the 12th times y to the 4th, 27 times x to the 2nd times y to the 16th, 2/3. Okay, so again, it's all multiplication. There's no radical. You do not make a parentheses off to the side. So in the numerator, you got 8 times x times y. Denominator, you get 27 times x times y. So 1 times 2/3 is 2/3. 12 times 2/3 is 8. 4 times 2/3 is actually 2 2/3. 1 times 2/3 is 2/3. 2 times 2/3 is 1 1/3. Okay. And 16 times 2/3 is going to be 10 2/3. Now, get rid of some of these variables. You'd subtract the 1 1/3 from the 8, and that's going to make 6 2/3. Then you subtract the 2 2/3 from the 10 2/3, and that makes 8 whole. Okay. None of these are negative. 2/3, I don't see a negative anywhere. Okay. So what do you have for wholes? Well, you got a 6 with a base x and 8 with a base y. X 6, y 8. Those can be forgotten. Now fractions, you got a 2/3 with a base of 8 on the bottom, on top I should say. And then you still got that 2/3 with the 6 2/3, and you use the base of x. Okay, now down in the denominator you got the 2/3 with the 27 base. Now you need to circle those denominators and see if you can find the cubed roots of that stuff. So the cubed root of 8 is 2, so this is now 2 to the 2nd power, 2 to the 2 power. The cubed root of 27 is 3, so this is now 3 to the 2 power, okay? Now, do we have any more fractions? No, no, yes, no, no. But this one fraction, at least it ain't on bottom, okay? It's not in the denominator. Okay, so if x to the 6th times 2 to the 2nd, and when I get to my radical, I make a cubed root and put x squared inside. Then I have y to the 8th and 3 to the 2nd. Okay, now outside the radical, 2 to the 2nd is 4. You can't simplify x to the 6. 3 to the 2nd is 9, okay? Y to the 8th. And then you're going to have your cubed root over x to the 2nd, okay? Now I have 2 of these on this packet. There's only 1 of these on the test, okay? Same thing, division with radicals. So they're both cubed roots, so you make one parenthesis. You're going to have to go back to rewriting the problem now that we have radicals. You got x over 2. You can't divide, really simplify anything. So I got an x, I got a 2. Both of those go to the power of 1/3. Okay. No negatives. Now, you don't have any whole exponents, you just have the fraction exponents. Can you find the cubed root of x? No. Can you find the cubed root of 2 right away? No. Okay. So the fractions are there. Now we have it on bottom, okay? So we need to go down here. You write your top down, x to the 1/3. Then you write your 2 to the 1/3, and you need to times by another base of 2 with a 3 as the exponent in the bottom. Now 3 minus 1 is 2, okay? Now, and I got to remember that goes on top 2. Now what happens down here is we write 2, and if you add those powers, it's 1 whole, so that's just 2. So I know in the denominator I'm just going to have 2. Now I still do have the fraction powers on the top, okay, cubed roots. So I make a cubed root, okay. X to the first, you can just actually do the 2 to the second first. 2 to the second is 4. Don't just write 2. If there's a top power that's not a 1, you got to take the base to that top number. Then x. So you got the cubed root, you got x inside, the cubed root of 4. You can try to simplify that, but you're going to quickly look at your list and say 4 is too small to divide. So you're just going to keep the 4 in there. And no, you don't divide a radical 4 by a non-radical 2. Okay, number 10. These are both square roots. Okay, so now do I have the root? Yeah, so I rewrite that as a 1/2 power. So I have x over 2 times y. You can't simplify any of that. So you got x 2 times y. That's going to be a 1/2, 1/2, and 1/2. All right, so none of them are negative, so I don't have any full exponents, so I write all these halves. Keep stuff where it's at with a 2, and a 2. Okay, can you find the square root of any of those? Not x, not y, and 2 doesn't have a perfect square root. Okay, so with that being said, well, we got fractions, and yes, they're on the bottom, so we have to go here. So you write your top down right at the beginning. Now, write your 2 to the 1/2 power, and that means you need to times by another base 2, put a 2, and what's 2 minus 1? 1, okay? Okay, so this is going to be 2, 1/2 plus 1/2 is 1 whole. That's the whole point of it, okay? Now, you also got your y, okay? The y don't forget about the other one, because that's a fraction too. So you times by another y, and then 2 minus 1 is 1, but then you got to times that to the top. What you times by on bottom, you got to times by on top. And then I write y down, 1/2 plus 1/2 is 1, so it's just y. So I have 2 times y, 2 times y. Now I need to make a radical of a 2 for all of these rationals I have on top. So the square root, you got x1, 2(1), and y1. Put your 2 to the first, that's 2. Then x to the 1, you can just write x, and then if there's just a 1 up there, you can just write the variable. So you got the square root, x times y. Is it possible to simplify the square root of 2? No. Okay, so 2. Okay, now finally we get out of the multiplying and dividing. Now it's adding and subtracting. 18 square root 2mn minus or plus negative square root of 2mn. Now with adding and subtracting, I look at the radicals and they match. They're exactly the same, and if they are, it's easy problem. 8 plus negative 25 is negative 7. Okay, I got the square root of 50 minus 4, so plus negative 4, square root 18 plus 2, square root 32. So we have these plus signs here. Well, this time the radicals do not match. They're not like terms, so I bring them over here. Okay, I put the square root of 50, negative 4, square root of 18, and then 2, square root of 32. So you guys need to, you can put a 1 in front of that if you want, okay? So if you want to drop the 1, drop it. Now, is 50 a perfect square root? No. If it is, I just write the number over here and multiply, but it's not, okay? So you divide into your 50. And then the perfect square root, 50 divided by is 25. So you put 25, and then 50 divided by 25 is 2. So replace that with 5. 1 times 5 is 5, square root 2. So this is 5 square root 2. Okay, now I drop the negative 4. And see what 18 divides by. It's not a perfect square root, okay? 18 divided by 9 is 2. So this becomes 3. Negative 4 times 3 is negative 12, square root of 2. Now the last one, drop the factor of 2. 32, is that a perfect? If it's not a perfect square root, you got to divide, okay? So out of those perfect squares, 32 is divisible by 16. 16 and 2. Then, of course, we need to change the square root of 16 to its actual value, which is 4. And then 2 times 4 is 8, square root 2. Okay. Now, do the radicals all match? Indeed. 5 plus negative 12 plus 8. Okay, it's going to be 1. 1 square root 2. Really, if it's a 1, you don't even need to put that, but you got to put square root of 2 down. Number 12 is more adding, but first you got to run the FOIL method. Put 1s in front of your radicals, okay? If you have to FOIL, don't even waste time putting 2s there, okay? So you take 1 times 5, 1 times 1, times 5 times 1 square root 2. Okay. Done. Now, 1 square root 72 times 5. And then 1 square root 72 times 1 square root 2. See these pluses right there? Okay. They separate. You're taking this to this, this to this, and then underneath. 1 times 5 is 5. 1 times 1 is 1. There's going to be a square root of 2. 1 times 5 is 5. Square root 72. 1 times 1 is 1. Square root 144. Now, write those out. 5 plus 1 square root 2 plus 5 square root 72 plus 1 square root 144. Now you got it multiplied. Now you got to simplify. Well, the 5 can't be simplified. Now I write all those radicals with their coefficient number. 1 square root 2, 5 square root 72, 1 square root 144. And you're looking at the square roots, okay? So 2 is not a perfect square. Well, I might try to divide that, but it ain't going to work, so that's going to stay the same. It's too small. Drop your 5. Now, you got to divide 72 by the right number. You don't want to divide it by 9. Okay, I realize 9 works, but there's a higher perfect square it divides by, the 36. So 36 and 2. And the square root of 36 turns to 6. So now we have 30. 5 times 6 is 30, square root of 2. Now, guys, this one you got 1. Guys, 144 is a perfect square, so don't make 2 square roots. You just replace it with 12, and 1 times 12 is 12. Now I add the 5 and the 2 to get 7, and I add my radical terms. 1 plus 30 is 31. Okay, and that's the end of that. Now we're solving equations, okay? Solve the equation means you got to find the value of x, okay? Maybe there'll be 2 answers. Maybe there'll be, I don't know. I have to get rid of the radical first, okay? So we got 4 square root of x. By the way, the 4, it's not a 4th root. The 4 would be much smaller. It would be positioned right here. This is a square root. The 4 is a multiplier in the front. Then 3x minus 5, and after the radical, you got minus 5 equals 15. Well, first, you want to circle the radical and get rid of the crap outside. You got a times 4, a minus 5. So you're going to plus 5, and you're going to divide by 4 in that order. You got to get rid of your minus plus number first. It's 4 times the square root of 3x minus 5 equals 20. Then you divide by your 4. Because, yeah, you are going to do a second power, but before you can do that, you got to get rid of the operations outside the radical. Okay, a square root means you take each side to the second power, not the 1/2 power. That's not an exponent, it's a root, okay? Don't flip it, okay? So get rid of that, and you have 3x minus 5. Now over here, 5 to the power of 2 is 25. And you solve it, okay? It's going to stay at one answer. You're just using the linear properties model where you get the x by itself. It's 30. Divide by 3, you get 10, okay? Okay, number 4. Now this isn't a radical, it's a rational exponent. So when I have a whole parentheses to a power, the smartest thing I could do is to simplify it by replacing the quantity with h. So we have 3 times h to the 3/4 power equals 24. Now don't forget, we're gonna bring back the x minus 2. When I bring that h in, what I'm essentially doing is solving for the expression x minus 2, figuring out what that equals. Okay, so here's my power. Now you just got the times right there, so you need to divide by 3. You don't have to add or subtract. And I have h to the 3/4 power equals 8. Now, to get rid of a rational exponent, that's when you flip. Okay, flip it. So I raise both sides to the reciprocal power of 4/3. Now, we know how to do this. See if 8's a perfect cube. By the way, 3's an odd root. It's odd, so if it's odd, you don't need the plus minus. You don't need that. It's only the positive. Cube root of 8's 2. Okay, so it's 2, but don't forget the 4th power. So h is equal to 16. So you put 16 over there, and voila. So you add a 2 to both sides, and x is 18. Number 16, okay, still solving for x. Maybe there'll be a second answer at it. I got to get the radical to go away first, okay? If I have x inside a radical, I have no idea what type of an equation it is, whether it's a quadratic equation or a linear equation, until I get rid of the square root. Okay, it's a 2. So you got anything outside of that? No, you don't. So you go right to your second power. The square root and the second power cancel out. That's like a 1/2 and a 2. So that's 3x plus 7. Now on the other side, I can't just square a number. I got to square an entire expression. So I would want to duplicate that. Okay. So I take 1x times 1x. 1x times -1. -1 times 1x. And -1 times -1. You're timesing these. 1x. X second, -1x, -1x, and 1. The multiplying's done. Now, simplify your expression, add any like terms. So you got a 1, -1 plus -1 is -2, and then you got 1. So over here you bring over 1x second plus 2x plus 1. Now, obviously at this stage, it's not just one answer, there's 2 because you got x a second. And when you have x second and there's also x's in the problem, you need to factor, okay? All right, so you got 2 sides. One side has to be cleared because when you factor, you want to use the zero product rule. So I subtract 3x from the 2x. I subtract 7 from the 1. So now I have my 0. I have 1x second. 2 minus 3 is -1x. 1 minus 7 is -6. Okay, that's a trinomial. Okay, so GCFT. GCF's 1. You can skip that if you don't want it. No x, no negative, it's just 1. Okay, now factor that trinomial. Find the 2 parentheses that would be multiplied out to get that. 1 times -6, -6. That is a mismatch of a positive negative. We have to add to -1. 1 and 6, nope. 2 and 3, yes. So A is equal to 1 times x seconds. So I place the 1 in. Divide your exponent in half, so it'd be x to the first, which is just x. A 1 and a 2, nothing. So that's just going to be x plus 2 times x minus 3. Now you're factored. Use your zero product property. X plus 2 could equal 0. X minus 3 could equal 0. Minus 2, I get -2. Plus 3, I get 3. Okay. Okay, domain and range, I forgot to put over here. I have them listed on the test so you don't forget to do it. Okay. Now, we have -2 times, the -2 is that's not in the root, okay? The root's a 2 plus 3, square root. Okay, so radical. First, I just focus on if I was just graphing y equals square root of x. Well, I would only want to pick perfect squares. 1, 4, 9, it keeps going that way, but you have to stop. You can't do negatives or not perfect squares. Okay, so if I put a 9 in there, what's the square root of the number 9? 3. 4 would be 2, 1, 0. But that's not all you got. Now look inside your radical. The plus 3 is not in the radical. Inside the radical, you just got x, so you're going to keep your inputs the same. There's no right, left translation. Now your stretch, okay, you have a -2 that you have to times by, and you also have a vertical translation of plus 3. So 3 times -2 is -6, plus 3 is -3. 2 times -2 is -4, plus 3 is -1. 1 times -2 is -2, -2 plus 3 is 1, 0, that'd be 3. Now you can just go by ones, so 0, 3, 1, 2, 3. Now you want to circle that point because you can't go to the left of that. 1, 1, okay. Connect. 4, -1. Connect. 9, -3. 9's all the way. Connect. Arrow. Keeps going that way because remember, you can go 16, 25, all the perfect squares till infinity. You just can't do negatives. Okay, so the domain puts at, by the way, you don't put the arrow on this end because remember, anything this way is negatives for x. Okay, you can't have that. So x was 0, y with 3. Now look at your graph. These are greater than 0. 1, 4, 9 are. So greater than or equal. 1, -1, -3, those are less than 3. Okay, so less than or equal. Okay, and then last one, number 18. Okay, so it's a radical, so write what kind of radical you have and just put x inside of it. So only perfect squares, 1, 4, 9. That can keep going. That's why you put an arrow to the right, but not to the left. So that's what makes a domain range restriction. Now inside the radical, this time we have plus 1. Well, then you have to do left, right with the x, okay? Now if you got plus 1, you can do the opposite and just minus 1, or you could say, okay, x plus 1 equals 0. I get -1, which hence means I'm minusing 1, okay? Now outside the radical, you got -5. So there's no stretch to it. Oops, I better put 3, 2, 1, 0. No multiplication stretch, but just a downward shift, okay? So 8, 3, 0, -1, -2, -3, -4, -5. Okay, so -1, -5, left 1, 1, 2, 3, 4, 5. You better circle that, okay? Okay, 0, -4. Connect. 3, -3, 1, 2, 3, 1, 2, 3. Connect. And then 8, -2. Now I keep going this way, and I could keep going that way, but I can't go this way, okay? So it's actually the same as this, just all your points are 1 left and down 5. Okay, so domain x, -1, y, 5. So 0, 3, 8, that's greater, okay? This is a greater than or equal to sign. Points this way, -3, -3. You're going higher there, so that's greater, okay? See, that's your domain range. That's your domain range point. Now you got to figure out how it's working out. Those numbers are bigger than -5, so greater than or equal to.